To that point, we need to understand which nutrients limit growth the most, which is the most limiting nutrient, and which is the one that's constraining the cycling of all the other elements, if not the growth of plants. And what controls those most limiting nutrients? So why are they supplied at such a low rate to limit the cycling of other elements and the productivity of the system? At its most basic level, nutrient limitation to plant growth is defined operationally as occurring where additions of a nutrient or nutrients enhance the growth of plants. So, measuring supplies of nutrients to plants and then their requirements is not necessarily easy. And to do that for 22 different elements becomes really hard. So often what's done is that you'll have a fertilization experiment where you can add different resources. So you might add nitrogen, you might add phosphorus, and then compare that to control where no elements have been added. And then take a look at the response take a look at the productivity and the control, and then take a look at the response that you might see in productivity where you've added those nutrients. And the one where productivity is increased the most is considered often to be a limiting nutrient. But we also can have the situation where more than one element is added. More than one element which is added increases productivity. So when we think of a system that's limited by nutrients, we tend to think of that as an oligotrophic system. So the potential productivity for a site based on the amount of water that's added, its temperature, for example, most of the state factors could be something like this, and then an oligotrophic system, that difference in productivity is really high. So when an ecosystem is really strongly limited by a nutrient, we tend to think of those as oligotrophic systems. Those systems where the actual productivity and the potential productivity are pretty close, we consider eutrophic systems. So oligotrophic, oligo means few, and it's the idea that it's relatively low. Eutrophic means good, but it's essentially oligo is a low productivity system, a eutrophic system is a high productivity system relative to its potential. Now, the situation where we determine which nutrient is limiting simply by doing additions has complications. And the authors go through some really good examples of understanding the different degrees of limitation. And degrees in the sense that you can add a resource and see an increase in productivity. But it doesn't mean that that's the only one that limits. And you can have a situation where you can have ultimate limitation by one resource and proximal limitation by a number of resources. Distinguishing whether there's an ultimate limitation or a proximal limitation and something in between, a distal limitation, is not easy, and it takes time with our addition experiments. The example that they use is, again, what I'll call Schindler's Lakes. These are lakes up in Canada where there was a series of studies done to determine which are kind of the proximal limitations, so which elements proximally limit productivity in these lakes compared to the distal or the ultimate limitation. And the examples that they show is that there's a whole series of incubation studies where they could take lake water and do additions. And what they found is that if you added nitrogen, if you added phosphorus, or CO2, you would get an increase in productivity in the water. So more plankton would be produced just by adding each of those. But only one of these elements was necessary to increase productivity long term. Because when you added nitrogen, for example, you would get a short-term increase, and then that would decline over time. Add CO2, the same thing. Productivity would go up short-term, but long-term productivity levels would be similar. Add phosphorus, though, productivity levels would go up, and they would stay high. So somehow, increasing the amount of phosphorus in a lake also increased nitrogen and CO2, and it was considered to be the ultimate limiting factor or a distal limiting factor. whereas nitrogen and CO2 were just proximal. Now, whether you use the word ultimate or distal depends on your viewpoint, because there might be another factor that's determining P availability. So this X factor could be determining P availability that then determines the availability of nitrogen, CO2, and phosphorus, which then determines the growth of phytoplankton. So it's easier to just call this a distal limiting factor than an ultimate limiting factor. So that way there's nothing behind determining why phosphorus is limiting. Still, whether you call it a distal or a proximal, it's the same. Distal or ultimate, it's still the same general idea. So in this case, when they did these additions of nitrogen, CO2, for example, and phosphorus in lakes, adding P to the lake had caused a chain reaction. Adding P increased the abundance of cyanobacteria. And what cyanobacteria can do is fix nitrogen. So they actually increase the amount of nitrogen in the water. So adding P increased the amount of nitrogen, and adding nitrogen increased productivity, which to a certain degree increased the CO2 supply to the water. So nitrogen was still limiting, CO2 was still limiting, but P could be considered a distal limiting factor that increased nitrogen availability and CO2 supplies, such that all three of these can be considered limiting, but it was P that was the distal limiting factor. So phosphorus limitation in this case was considered distal, or what the authors say is ultimate. And more than likely I'm just going to use distal instead of ultimate, because we can never be sure if it's the ultimate factor or if there's something that's determining its availability. Nitrogen limitation still occurred, but in this case it was proximal and not distal. If we added nitrogen, that didn't necessarily increase the phosphorus supply to the lake, and therefore it wasn't considered a distal factor. Now, one of the things that we're still trying to work out in ecosystem ecology is really thinking about potential supplies. And with nitrogen, there's really an unlimited potential supply. So there's enough N2 in the atmosphere that if that's fixed, there would be more than, even a small fraction of the N2 in the atmosphere is fixed, that's more than enough nitrogen to saturate all the ecosystems on the Earth. And so all it takes is having the right plants, the right amount of energy, and the right amount of other factors like phosphorus to fix huge amounts of nitrogen. That doesn't happen though. And so although we have an unlimited potential supply, the actual supply for nitrogen is a lot less. So you can see where it's pretty tricky to understand which nutrients are limiting and why. Nitrogen's limiting, but there must be something that's limiting to an ecosystem such that nitrogen isn't being fixed at a high rate. So when we think about limitation, we're going to think about which nutrients are going to be limiting, but also the relative degree of limitation. So proximal versus distal, and then the authors use this word ultimate that I'm probably not going to use much. So distal versus proximal limitation. And essentially, one way to figure that out is to do long-term studies where you've added a resource, you add an element, and then you wait a long time to see whether productivity stays high or whether another factor becomes limiting and causes productivity to decline in the long term.